Right, how do we implement this get negative sample? Let's do this together. First of all, we're going to get word P. This is the probability of each word. And we get target index. And we're going to set the probability of target index as 0. Because we don't want to sample target word or target. That's why we are setting 0 for that target word. And we normalize this probability once again. And how do we gather negative samples for this ith batch? We are not going to implement this manually, but there is a very useful function provided by NumPy that is NP random choice. We just pass the vocab size and the size of sample we want to get, and we are not going to replace, and we pass the probability. And this will sample the number of sample size samples. Okay, so by using random choice, this becomes pretty easy to implement. Okay, we've completed the implementation of improved version of CBOW. And how do we write the training code? Basically, the training code is quite the same. You can use this one as well. But there might be some differences. We can use the same hyperparameter setting. And rather than passing this simple text, we can pass the PTB dataset. And we also need to create context and target. However, we don't have to convert target and context into one-hot vectors because our implementation became very efficient. We don't have to do this. And by the way, we're using binary logistic regression. So we don't need one-hot vector at all. And we create model rather than simple CBOW. We create CBOW or skipgram. And we do the same for optimizer, trainer. That's the beauty of this trainer class. Okay. And after we finish training the model, we can play with the trained word vectors. Okay. Or we can use Pickle to store the parameters we've trained. All right, that was about CBOW. And the next thing is improved version of skipgram. This is a PPP exercise. Referring to this CBOW, try to implement this skipgram on your own.